In this video, I am going to talk about second order constant coefficient homogeneous differential equations. The general format for this type of differential equations is this: a times y double prime, where a is a constant, plus b times y prime, where b is a constant as well, plus c times y, c is a constant as well, is equal to 0. The homogeneous part comes from the fact that the right side of the equation is 0, right? And the constant coefficient comes from the fact that the coefficients of y, y prime, and y double prime are all constants. And we are assuming that these constants are real numbers. So that means a, b, and c are elements of the real number, r. Now, I'm going to outline how to solve these types of equations. From our experience of dealing with simpler second-order linear differential equations, or second-order constant coefficient homogeneous differential equations, we kind of know that the solution will be of this format. Y is equal to y of t is equal to e to the power or some number, some parameter times t of this format. That kind of gives us y prime is equal to r times e to the power rt, and y double prime is equal to r square times e to the power rt. Okay, so r is a number, or r is a parameter that we need to find here. So now, since from our experience we found out that e to the power rt, or the general structure for this type of differential equations, okay, the solution for this type of differential equations is e to the power some constant times t, we kind of are going to assume that, oh, okay, so this is going to be the solution, and we are going to go ahead and plug it in and see what we get. So if I do that, a times y double prime, but y double prime is r squared times e to the power rt, plus b times y prime is r times e to the power rt, plus c times y, and we assume that our y is going to be this, c times e to the power rt. Now, it is a homogeneous differential equation, so the right hand side is going to be 0. Now, I could go ahead and factor out e to the power rt. That's going to give me a r squared plus b times r plus constant c is equal to 0. Now look, if you just look at this equation, you notice that the product of two things is equal to 0. So either this one is 0 or that one is 0, or it's possible that both are 0 too. But let's look at the first term, e to the power rt. This is an exponential function, hence never 0. It's never 0. Therefore, it must be the case that the other term or other factor is 0, which tells me that a r squared plus b times r plus c must be equal to 0. Now, this is nothing but a quadratic equation, and you know how to solve. So the quadratic equation in r, so it's going to be r is equal to negative b plus or minus square root of b squared minus 4ac divided by 2 times a. So that's going to be the solution. In this particular scenario, we kind of have three scenarios. So R has three possibilities. One possibility is that the solutions, so these values are distinct. Okay, so distinct means you will have R1 and R2. Second possibility, these are real numbers, two distinct real numbers. Second possibility is that it repeats the solution. There is only one solution, R1, and that is going to be the case when b squared minus 4ac is going to be equal to 0, the discriminant. And also in this case, b squared minus 4ac is going to be greater than 0. So if the discriminant b square minus 4ac is greater than 0, you will have two distinct solutions for r. If the discriminant is 0, then you will have one solution, it repeats twice. And the third scenario is going to be if discriminant b square minus 4ac is less than 0, in that case you will have complex solutions. Complex. But in the case of complex numbers, as you know, for quadratic equations, you get solutions that are conjugates of each other. Conjugates of each other. In case you don't remember what conjugates are, very simple. It's very simple. So what it is, let's say 1 plus I is a complex number. The conjugate of it is going to be 1 minus I. Basically, you change the sign in front of the I, or if you have 2 minus 3i, the conjugate of that is going to be 2 plus 3i. All right, so that's how you'd solve this quadratic equation, but in this particular case, we are going to kind of address only this guy, okay, where we have distinct solutions. Now, what happens here is this. You have two distinct solutions, so your y1 is going to be equal to e to the power r1 times t, okay, and your y2 is going to be e to the power r2 times t. So these are solutions to the differential equation. However, any linear combination of these two are also a solution. So we are going to have y of t is equal to c1 times y1 plus c2 times y2, which I could rewrite as y of t is equal to c1 times y1 is e to the power r1t e to the power r1t plus c2 times y2, which is e to the power r2t. So this is the general solution. Okay, so this is a family of solutions which is infinitely many, right? However, how do we find out any particular solution? That would depend on the initial conditions. Initial condition. Okay. So if we provide initial condition, that would help us to find the constants C1 and C2. Once we have that particular solution. So remember, we have a family of solutions here, but initial conditions are gonna define particular solution that we are looking at. This is how you'd solve a second order constant coefficient homogeneous differential equation which has this structure. I hope that this discussion was helpful. Thank you very much.